Good morning, good afternoon, and good evening to each and everyone, depending on which moment or time of the day you are watching this video. So I am Dave Francis S. Archaga, and this is ENS 162, Dynamics of Rigid Bodies. So in our semester, we talk about statics. Basically, these are objects that are at still or are not in motion. While in dynamics, we will be studying the principles of dynamics. So what do you mean by dynamics? So dynamics, in layman's term, is simply studying, is a branch of mechanics that deals with the study of the bodies that are in motion. So this time in dynamics, we are dealing with bodies that are in motion. In motion. So there are two branches of dynamics. These are kinematics, and kinetics. So in kinematics, this is study about the relationship between displacement, velocity, acceleration, and time without the consideration of the forces causing the motion. So without consideration to the forces causing the motion. Kinetics, on the other hand, is used to relate the force acting on a body to its mass and acceleration. So this time I'm gonna write it first. Used to rate the force acting to its body mali ang grammar ko. Acting on a body to its mass and acceleration. So in kinetics, there will be forces. Forces are held accountable whenever you are solving. While in kinematics, we are not including the forces in our solution. So here are some of the differential kinematics equation of motion. So these equations will be very important later on. So D is equals the dx over dt velocity. V So here are some of the differential kinematics equation of motion. V is equals to dv dx over dt, where x is displacement and t is time. Acceleration is equal to dv over dt, and third is derived from the two v dv is equals to a dx. So without further ado, let's start the chapter Kinematics of Particles, chapter 11. So under chapter 11, Kinematics of Particles, we have rectilinear motion. So a particle moving along a straight line is said to be in rectilinear motion. So whenever a particle is moving along a straight line, for example, this is 0, this is 3 meters, if an object moves along this line, the x-axis, that particle is said to be in rectilinear motion. So to further understand, let's answer this problem. The motion of a particle is defined by the relation x is equals to t raised to 4 minus 10t squared plus 8t plus 12, where x and t are expressed in inches and seconds relatively. Determine the position, the velocity, and acceleration of the particle when t is equals to 1 second. So given t is equals x is equals to t raised to 4 minus 10t plus 8t plus 12 at t is equals to 1 second. So using the formula that I have introduced earlier, v is equals to dx over dt. So from this equation, we are going to derive it. So 4t cubed minus 20t plus 8 and acceleration, since acceleration is also asked, a is equals to dv over dt. Ano itong answer? So A is equals to dv over dt. So we need to differentiate this once more. So 12t squared 12t squared minus 20. So why do we have to differentiate this? Because acceleration is in terms of dv over dt. So if this is our v, 4t cubed minus 20t plus 18, so dv over dt is just 12t squared minus 20. So substituting t is equals to 1, the position of a particle at t is equals to 1. So 1 raised to 4 minus 10 raised to 1 squared plus 8 times 1 plus 12. We have 1 minus 10 plus 8 plus 12. So the position of a particle at t is equals to 1 second is equals to 11 inches. Now the velocity, using this equation, v is 4t cubed t 40. So ang t is 1 second, so t cubed minus 20 t is 1 second plus 8. So we have 4 minus 20 minus 20 plus 8. So velocity natin is negative 8 inches per second. So if ang velocity natin is negative 8 inches per second, how about yung acceleration? Acceleration natin is 12t squared minus 20. So again, substituting the value of t, which is 1 second, so 12 minus 20 is equals to 8, negative 8 inches per second squared. So we have the answers. Position at is 11 inches at 1 second with a velocity of negative 8 inches per second and an acceleration of negative 8 inches per second squared. Now, in rectilinear motion, when there is a uniform rectilinear motion, what does that mean? So, uniform rectilinear motion happens when there are zero acceleration. That means constant velocity. So the equation or the formula for that will be the formula for the uniform rectilinear motion is simply x over x of 0. X of 0 plus VT. Okay. Plus VT. VT, while in uniform accelerated rectilinear motion, this happens when the constant acceleration. So in here, zero acceleration. Acceleration. Here, the acceleration is constant. Constant acceleration. Constant acceleration. So V, these are the formulas. V is equals to V sub 0 plus AT. And X, where X is displacement, X is equal to X sub 0 plus V sub 0 over T plus AT squared over 2. And lastly, V squared is equals to V sub 0 squared plus 2a which is acceleration times displacement, which is simply x sub 2 minus x sub 1. So we have to remember these equations because they are very important.
So in the program we have, it's stated in the program that stone is thrown upward and reaches back to the earth at 10 seconds. This is the V1 is equals to 0 and V2 is equals to 0. And this will be the height at which the ball reached its highest point. So using the formula, V2 is equals to V1 minus G T sub 1. We are using G because the acceleration is due to gravity. So our V2 is equals to 0 is equals to V sub 1 minus G T1. So equating this formula, we have T1 is equals to V1 over G, which also simply means V1 is equals to T1 times G. Now, before we can answer the question, it's that is asked, the initial velocity, we have then again to use another formula. V squared, V sub 2 squared is equals to V1 squared minus 2. Again, since in terms of gravity tayo, G ang ating gagamitan times height. 0 yung V2 natin is equals to V1 squared minus 2G H is equals to V squared over 2G. So we have H is equals to 1/2 GT squared. So equating this, we have 2H minus G. Edit out. Tito yung gamitan, Tito squared. Kaya para makakuha kang Tito. Yeah. So in order for us to have time 2, we already have time 1. Let us use this equation. H is equals to... Let us use this equation. Let us use this equation. Balik. So in order for us to have T2, since we already have T1, let us use this equation, 1/2 G T sub 2 squared. So equating, we have 2H is equals to G T sub 2 squared. So T2 is equals to 2h over g. T sub 2 squared. So T sub 2 is equals to the square root of 2h over g. So in totality, our T time is simply T1 plus T2. So you may be asking, what is this T1 and T2? T1 is the time that the rock reaches from point here to here, and the T2 when it comes back. So the total time, it was said in the problem that it was 10 seconds. Is because T1, we have T1 right here, V sub 1 over G plus T2. T2 is simply square root of 2H over G. And RH is V sub 1 squared over 2G. So let us replace H with V initial velocity squared over 2G. So 10 is equals to V1 over G plus square root of 2 times V1 squared over 2G G. Cancel. So we only have V1, inside the square root we have V sub 1 squared G over G. So yung square root nito is simply V sub 1 over G. So 10 is equals to V sub 1 over G and plus ito V1 over G. G? So 10 is equals to 2 V initial velocity over G. So equating, we have 10 is equals to 2V 1 times 9.81 meters per second, because this is the gravity. So 10 equals to x. 2x over 9.8. 81 shift solve. So per x. V1 is equals to 49.05 meters per second. So this will be its initial velocity. Now, for the highest height it travel, let us use this equation. H is equals to V sub 1 squared over 2G. So alam na natin yung V initial velocity natin, which is ito. So 49.05 squared over 2 times 9.81. Plugging it in our calculator, we have 49.05 squared times 2 divided by 9.81. We have 122.625 meters height. So yung height that the ball reached is 122.625 meters, or rounding it off, 122.63 meters. Now for the last and third question, the time it reaches the highest point. So ilang time daw before it reach its highest point? So from here, so if this is the highest point, how long, or the time, how long is the time before the ball reaches its highest point? So using this equation, T is equals to V over gravity, initial velocity. T is equals to 49.05 meters per second divided by 9.8. T is equals to 5 seconds. So the time from initial velocity when the ball is still on the ground, when it reached its highest point, it took 5 seconds. That would be all. Thank you.
So we have here a curvilinear motion of particle. So what do you mean by curvilinear motion of particle? A particle moves along a curve other than a straight line. We say that that particle is in curvilinear motion. For example, we have here, let's change it into white. So we have here your y-axis and your x-axis, and this is your particle motion. For example, at this point, we have to find v sub x, which is the horizontal component of the velocity, and it's vy, the vertical component of the velocity, to find the find v, which is the velocity. Velocity is equals to square root of vx 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 squared plus vy squared, where vx is simply dx over dt and vy is also dy over dt. Now here as tan, also I forgot, tan theta x is equals to vy over vx. Here are some of the formulas that we could use, other formulas that we could use to solve particles that are in curvilinear motion. So in the y component, or the y vertical plane, you can solve x is equals to tan theta minus gx squared and gx squared all over 2v squared cosine squared theta. Also, we could use this, y is equals to v sine theta times time minus 1/2 gt squared. Also, we could use this, x is equals to v cosine theta times time. So to further illustrate these formulas that we have, this is the y-axis, x-axis, y-axis. To further illustrate these formulas that we got here, let's solve a...
So we have a milk that is poured into a glass that is 144 millimeters tall. So for example, this is the glass, 140 mm, with a diameter of 66 millimeter, and the initial velocity vi 66 mm. Vi is equals to 1.2 meters per second at an angle of 40 degrees with horizontal. So for example, ito yung horizontal axis is we have 40 degrees. This is point B, this is point C. So determine the range of values of the height for which the milk will enter the glass. So we have V in the x-axis. This is the initial. We have 1.2 meters per second times natin to cosine 40 degrees. We have 0.91925 meters per second. And the y-axis, Vy, is equals to negative 1.2 meters per second. Negative because it is going down. Sine 40 degrees, we have negative 0.77135 meters per second. So in horizontal motion, we have this equation. X is equals to 0 plus Vx 0 times the time. While in vertical, we have y, vertical motion, we have y is equals to y sub 0 plus Vy 0 times T is minus 1/2 GT squared. So when the milk enters, there will be two scenarios. The height, we are looking for the height upon the milk will range from this point to this. So if we lower our milk, there is a tendency that the flow of the milk will go here. Or if we rise the milk, if itataas natin yung milk, may tendency na papupunta siya dito sa point C. So yung tinatanong is at which height para yung milk natin is papasok lang dito sa point B at C at saka D siya matatapon. So milk enters glass. Milk at point B. Point B. So the x-axis, we have, also I forgot to mention, the distance between the milk and the glass is 80 mm. The x-axis, we have 0.08 meters is equals to Vx, 0.91925 meters per second times time. We have T is equals, T at point B is equals to 0.087028 seconds. The y-axis, 0.140 meters. Dito galing yung 140 is equals to negative HB, height ng B, plus negative 0.77135 times natin sa time, which is 0.087028 seconds, is equals to negative 1/2 times natin into 9.81 meters per second squared times natin sa 0.087028 squared. So ang HB is equals to 0.244 meters. So yung height daw at which yung milk is papasok dito sa range ng B is 0.44 meters. Also 244 millimeters. Yung height ng milk para makapasok siya dito sa point B. Now, at point C, sa x-axis na naman tayo, we have 0.146 meters is equals to 0.91925 T, or T at point C is equals to 0.158825 seconds. So why naman, we have 140. You may be asking, saan galing tong 144 meters? It is simply 80 plus 66 meters because the distance of the milk up to point C is 144. So, going back, for the y-axis, 140 meters, 0.140 meters is equals to HC. HC is the point at which the milk will reach the point C. Plus negative 0.77135 meters per second times natin sa time, which is ito, 0.158825 seconds. So again, 1/2 times 9.81 meters per second squared times natin sa 0.158825 squared. So ang HC natin is equals to 0.386 meters, or simply 386 millimeter. So yung height daw, point C, so if ito yung milk, ang height nito from here to here is 386 mm para yung flow ng water niya or ng milk is papunta dito sa point C. While dito na naman sa point D, yung height niya is 244 meters. Yung height ng milk para makapunta siya dito sa point B. Meters, 244 millimeters. So the question is, what is the range? So the range is simply 0. Range natin is between the two. Range is equals to 0.244 meters less than h, then h must be greater than less than 0.386 meters. Ito yung sagot.
Non-rectangular components, tangential and normal components. So, sometimes kasi it is convenient to to resolve the velocity and acceleration of a particle P into components other than the rectangular x and x, y, and z component method. So for this example, let us use a sub n is equals to v squared over p. Now in this problem, a golfer hits a golf at point A, the velocity of 50 meters per second. So, mabilis yung velocity niya is 50 meters per second. Velocity 50 meters per second. So, 50 meters per second at angle of 25 degrees in the horizontal axis. So, if ito yung golfer, ito yung bola, ito yung trajectory niya, yung angle nito, tsaka ito is 25 degrees. Now, determine the radius of the curvature of the trajectory described by the ball at point A. Ito yung point A. And B is at the highest point of the trajectory. So, we have this equation. A N is equals to V squared over A. At point A, acceleration at point A is equals to V squared A. This is point A of P A. This is the curvature. Now, so we have a transpose natin ito. We have VA is equals to 50 meters per second squared kasi squared yan, over acceleration natin due to gravity is 9.81 meters per second times natin syempre sa angle because it is it has an angle cosine 25 degrees. Cosine siya because the angle lies on the horizontal axis. So with that, we have the PA is equals to 50 meters squared over 9.8 seconds, 9.8 meters per second times cosine 25. We have the answer is 281 meters. So this is chapter 12, kinematics of particles using Newton's second law. So in dynamics, Newton's second law is very important because it guides us, or it helps us solve particles that are in motion. So okay, so this is kinematics of particles, chapter 12, Newton's second law. So in this chapter, it was devoted to Newton's second law and its application analyzing the motion of particles. So in statics, we only used Newton's first law and third law. Here in dynamics, Newton's second law is very, very applicable. So Newton's second law of motion, if the resultant force acting on a particle is not zero, the particle has an acceleration proportional to the magnitude of the resultant and in the direction of the force. That means that if the force is going to the right, its acceleration is also going or pointing to the right where the force is pointing to. Oh. So in here, F1 is over A1 is just equals to F2 over A2, and F3 is equal over A3 is just equal to F4 over A4, and so on and so on. That means that there is a constant mass among them, because F or the force is just proportional to acceleration. So when there are multiple forces, we sum up or the resultant of all forces acting on a particle, we sum them all up. So we have summation of F is equals to ma. So linear momentum of particle is only L is equals to m, which is the mass, times velocity, and derivation of L prime is equals to d over dt times mv. So summation of F is just equal to L prime. Systems of unit. The two systems of unit that we use, SI unit, the International System of Units, and English system. So in SI unit, we use meter. And in English, we use foot. While at mass, the SI unit we use in kilograms, and in English system we use pound. And when it comes to time, they are the same. We use seconds, and in acceleration we use meters per second squared, while in English system we use feet by second squared. So this is the conversion of one system of units to another. So 1 foot is just equal to approximately 0.3 meters, and 1 pound is just equals to approximately 4.4 newtons. And in mass, 1 slug is just equals to 1 pound times s squared is over feet is just equals to 14.59 kilograms. So when we are using in kinematics of particles, especially in Newton's second law, we use kinetic diagram. This is to ensure that it is easy for us to solve, because if we use free body diagram, there are lots of components that are involved, and kinetic diagram simplifies what we only need to solve. Gives us the given data that are needed for us to solve. So equations of motion. So in rectangular component, we have summation of force I, j, and k is just equals to mass times acceleration in terms of I, j, and k. I, j, and k, that means this is in three-dimensional plane, because I, j, k is just like x, y, and z. Tangential and normal components. So we have this formula, summation of ft is just equals to ma, where we already know a is equals to dv over dt. So knowing that, we just dv over dt. So with that being said, let's just ipalit lang natin itong dv over dt sa a sa formula. So we have this summation of ft is equals to mass times dv over dt, or in we have this v squared over p in normal components. When tangential, we have dv over dt. In radial and transverse components, we have this. In radial, f r is equals to m times acceleration r, where r is just equals to r double dot minus r times theta dot squared. And in transverse components, we have summation of f theta is equals to, with respect to theta, is equals to m times acceleration with respect to theta. Okay, so sample problem. Astronaut who landed on the moon during Apollo 11, 15, 16, and 17 missions brought back a large collection of rocks. Knowing that the weighted rocks is 139 pounds when they are on the moon. Determine the weight of the rock on the earth. The mass of the slug acceleration due to gravity on the moon is 5.3 feet per second. So we know that mass is equals to weight over gravity. The weight of the rock when it was weighed is 139 when they are on the moon, times the gravity. The gravity of the moon, acceleration due to gravity, is 5.30 feet per second. So 139 over 5.30 feet per second, we get 26.226 pound per s squared over feet. So this is the mass of the moon when it is this is the mass of the moon, whether it is on earth, in moon, or in other planets. This is its mass. So when the rock is being brought back to earth, now earth has a acceleration due to gravity of 9.81 meters per second, but we are using feet, so we have 32.2 meters per second. So multiplying the mass of the rock, 2.226 times 32.2, the weight of the rock on earth, this is on earth is 844 pounds, and the mass of the rock in slug. So since one slug is just 1 pound, so m is just 26.2 slugs. Sample problem number 2. A 400 kg satellite has been placed on a circular orbit 150 kilometers above the surface of the Earth. The acceleration due to gravity at this level is 6.43 meters per second squared. Determine the linear momentum of the satellite, knowing that the orbital speed is 25.6 times 3 times 10 raised to 3 kilometers per hour. So since we have the mass of the object is 400 kilograms, and its velocity is 25.6 times 10 raised to 3 kilometers per hour, we have to convert this kilometers per hour into meters per second. So if we have we could just divide it, multiply it in 1 hour is equals to 3,600 seconds. So we have the velocity in In terms of meters per second, we have 7.111 times 10 raised to 3. So we have linear momentum is mv, so we are talking about the linear momentum of the satellite. So m is 400, velocity is 7.11 times 3 raised to 10 meters per second. The linear velocity, therefore the linear velocity is 2.84 times 10 raised to 3 kilograms times meters per second. So angular momentum. We define the angular momentum HO of the particle about a point zero is point O as the moment of O of the linear momentum mv of that particle. Thus HO, angular momentum, is just equals to R times m times v. So HO is a vector perpendicular to the plane containing R and mv, and has a magnitude of HO is equals to R times mass times velocity sine theta. Angular momentum. In the case of particle moving the plane xy, we have z is equals to v squared. Vz is equals to 0. The angular momentum is perpendicular to the xy plane and is completely defined by its magnitude. We have this formula. So computing at the rate of change h sub 0 of the angular momentum HO and the pi Newton second law, summation, we have summation of MO is equals to H dot O. This equation states that the sum of the moments about O of the forces acting on a particle is just equal, and the moments is just equal to the rate of change of the angular momentum particular. They are just equal. So when the only force acting on a particle P is the force directed towards or away from a fixed point O, the particle is said to be moving under a center force. So if the force acting on particle P is a force directed towards or away in the fixed point O, particle is said to be under center force. So since summation of moment O is equals to 0 at any given instant, it follows from summation of MO is equals to HO, that HO is equals to 0 for all values of t, and thus HO is constant. The angular momentum of the particle moving under a center force is constant, both in magnitude and in direction, and the particle moves in a plane perpendicular to the vector HO. So recalling, HO or the angular momentum is just equals to this R mv sine theta, and R squared theta is just equals to H, where H is the constant representing the angular momentum per unit mass, HO over m of the particle. Newton's law of universal gravitation. This is Newton's law of universal gravitation, where G is the constant gravitation and where m is the mass of the earth and r is the radius of the earth. Sample problem number 3. A particle of mass m is projected from point A with initial velocity v or perpendicular to line OA. Initial velocity perpendicular to line OA and moves under a center force F directed away from the center force O. Knowing that the particle follows a path defined by the equation this, and using equation from 12.27 express the radial transverse components of velocity v in the particle function O. So using this equation, or this solution, so VR is just R dot is equals to D derivative of R d theta times theta dot. It's just equals to R sub 0 is times sine 2 theta all over cos 2 raised to 3/4 times theta dot. So VR, we have this, VR is equals to V sub 0 sine 2 pi over square root of cosine theta. And in transverse component, we have this. Velocity theta is just equals to h over r, which equals h over r, where r is sub 0 times v sub 0 over r0 times cosine 2 theta. We have this and ito. A particle of mass m is projected point A, initial velocity VO, speed. Ito, iba na naman ito. Vinegar oil moves under a center force along a semicircular path. Kanina, hindi na-mention na path niya is semicircular. This time, the path is semicircular path of diameter OA. That R is equals to R sub 0 cosine theta, and using equation from 2.27 show that the speed of particle is V is equals to V sub 0 over all over cosine 2 squared theta. So solution, in radial component we have this. VR is equals to R dot is equals to derivative over dt times R0 cosine theta is just equals to R sub 0 sine theta times natin sa dot theta. When it comes to speed, velocity is just VR squared plus V theta squared is just equals to R sub 0 times theta dot, and we have this V is equals to V sub 0 all over cosine squared theta. Transverse component of velocity, we have this V sub 0 V theta is equals to R theta dot. R is just equal to R sub 0 cosine theta. So orbital motion, a particle moving under its center force, describe a trajectory. Orbital motion trajectory defined by differential equation. The d squared u is over d theta squared plus u is equals to f, the force, over m h squared u squared, where f is greater than 0 corresponds to the alternative force, and u is equals to 1 over rad, or reduce. In the case of the particle moving under the force of the attraction, we substitute f in this expression given in this gravitational law of Newton's law of universal gravitation. So measuring theta from the axis theta from the axis OA joining the focus O at the point A and the trajectory of courses to O. Figure out below. We found that the solution to d squared u over d theta squared plus u is equals to f over mh squared u squared is this. 1 rad or is equals to u, which is just equals to gravitational times mass over h2 plus c times cosine theta. Escape velocity. Escape velocity, this is where the needed velocity to escape the gravitational force. So the first of these values are called escape velocity. Is the smallest value VO for which the particle will not return to its starting point. Periodic time T of a planet or satellite is defined as the time required by that body to describe its orbit. We have T is equal to 2 pi AB over H, where H is R sub OV times O, and A and B represent the semi-major and semi-minor axis of the orbit. Kepler's law of planetary motion. Kepler's law of planetary motion can be stated as follows. The path of each planet describes an ellipse and the sun located at one of its foci. The radius vector drawn from the sun to the planet sweeps equal areas in equal times. The squares of periodic times of the planet are proportional to the cubes of the semi-major axis of their orbit. So, sample number 5. A particle of mass m is projected at point A. So this is the object, point A, with initial velocity perpendicular to OA. Initial velocity of OA and moves under a center force F. Force F along an elliptic path defined equation R is equals to R over 2 minus cosine theta. Using equation 12.27, show that F is inversely proportional to the square distance. Solution. U is equals to 1 over R is just equals to 2 over 2 minus cosine theta over R sub 0, and du over d theta is just equals to sine theta over r theta, and d squared u over d theta squared is equals to cosine theta over r sub 0. So solving for F, we have 2 times m h squared u squared over r squared is just equal to 2 times m times h squared over r over r sub 0 times r squared. Since h and r sub 0 are constant, F is proportional to 1 over r squared, and is inversely proportional. Chapter 13, Energy and Momentum Methods. Work and energy. Work and energy is from the principle of Newton's second law. F equals ma. F is equals ma. We could derive a principle of work and energy which states that we can obtain the kinetic energy of a particle at a sub 2 by adding its kinetic energy at a sub 1 at A sub 1 to the work done during the displacement from A to A sub 1 to A sub 2 by the force F exerted to the particle. With this formula, T1 plus U1 minus 2 is equals to T sub 2. So to further understand this work and energy, let's have a solution and an example. The subway train is traveling at speed of 30 miles per hour when the brakes are fully applied to the wheels on car A, causing it to slide on the track, but are not applied to the wheels from car A or B. Knowing that the coefficient of kinetic friction is 0.35 between the wheels and the track, determine the distance required to bring the train to a stop, and B, the force in each coupling.
So first, let us draw the train with its corresponding forces. For example, this is cart A, cart B, and cart C. 40 tons. Let's say 40 tons is equals to 80 kips. 40 tons is equals to 80 kip. And 50 tons is equals to 100 kip. So yung force niya pababa dito, since it's tons, meron tayong 80 kips. Well, dito we have 100 kips. And dito is 80 kips. Of course, meron yang yung mag-equal sa kanya. NA is equals to 80 kips. 80, then NB equals to 100. This is the normal force para. Normal force. I almost forgot. And C is equals to 80. So, if is equal to mu times normal force, point A, we have, since yung velocity, since yung kinetic friction natin, kinetic friction is equals to 0.35 between the wheels and the track. So if a mu natin is equals to 0.35 times natin sa 80 kip. Ito yung sa force sa cart A, ha? 80 kips. So plugging it in our calculator, we have 28 kips. V natin is 30 miles per hour. Convert natin ito into feet per second. So we have 44 feet per second, where V sub squared is equals to 0 and T sub 2 is equals to 0. So moving on, we have T1 plus V minus 2 is equals to T2 1 half times 80 kip. 80 plus 100 plus 80 divided by 32.2 feet per second squared. Second squared times 44 feet per second squared minus 28 kip is equals to 0. Yung x dito is yung distance. So solving it, so we have 280 to 2,860 is equals to 28. X is equals to pause. So we have 7,816.149,068 is equals to 28x. Divide natin. X is equals to 279.1 feet. Ito yung X. Ito yung distance required para yung train is ma-fully stop. Yes. Now, for each coupling, find natin yung forces. For car A, assume that force ng AB is tension. So, T sub 1, right, gawa muna natin. So, T sub 1 plus V1 minus 2 is equals to T2. 100 1 half times natin in 80 kip over 32.2 times natin 44 feet per second squared minus 28 ito is pa going this direction plus FB since same silang direction times natin sa X which is 279.1 feet is equals to 0. So 28 now sige ka na. So we have 2404.9689 minus 28 times 279.1 7,814.8 minus 279.1 FB. FAB. So, compute natin ito. We have 2409,689.7814.8 negatives yan. Basta negative 5409.83 equals to 279.1 FAB. FAB is simply negative 19.38 feet. Since negative man siya, tapos yung ano natin is tension, that means it is compression since it is negative. So FAB yung ibig sabihin nito, mali yung assumption natin na tension kasi negative yung sagot. So, kailangan positive yung sagot. FAB is equals to 19.38 kips, which is compression. So, instead of the force, assuming that the force is going this way, we should assume that the force is going that way. Now, for car A, car C, for car C, we have, draw natin, C, and yung weight niya, napababa, is equals to 80 kip. And C. Tapos, assume natin na it is tension. So, dito. Assume natin na tension, which is FBC. So, with that, we have T1 plus V minus 2 is equals to T2. So, 1/2 times 80 over 32.2 times natin to 44 squared plus, since positive yung direction ng force, positive din dito. FBC multiply lang natin into 279.1 feet is equals to 0. So, plug natin sa calculator. We have 1/2 times 80 over 32 times natin into 44 squared. We have 2,420. Since positive man to, then kailangan natin i-transpose. Ito na lang ang gawin nating negative. Equals to 279.1 FBC. Divide natin ito into 279.1. We have 8 FBC is equals to 8 negative 8.6707. Since na naman negative at saka yung nag-assume tayo na tension siya because away from the weight, papalayo. Tapos negative yung sagot. So yung sagot natin dapat is positive. So gawin natin itong, instead of tension, gawin natin compression. FBC equals to 8.67 kips, which is compression. So, ito na sagot natin. And
Conservation of energy. So when the work of the force is independent to the path followed, the force F is said to be conservative, and its work is equal to minus the change of the potential energy V associated with F. So this is the principle of conservation of energy. This T T sub 1 plus V E sub 1 is equals to T sub 2 plus V sub 2. This is the very important when it comes to conservation of energy. Yes, so to further explain this formula, let us answer this question.
Six inches, 0.5 feet. So, solve natin ang linear
momentum.
So, solve natin ang linear momentum. Solve natin ang length ng spring AC. Spring AC. Length niya is equals to square root of 1 feet, 0.5 times 0.5 equals 1 squared, plus 0.5 feet, 0.5 feet, feet squared. 0.5 because yung height dito from dito is 0.5. So we have 1.1180 feet. Ito yung distance niya. Tapos, change of length is simply equals to 1.1180 minus 0.5. Change of length niya is equals to 0.6180 feet. This is for spring AC. Spring AC. Now, spring CD. Spring CD, same formula. Solve natin yung length niya. 0.5. 0.5 na yung dito sa baba. Square root of 0.5 squared plus 0.5 squared is equals to 0.70711 feet. Change of length niya is equals to 0.70711 minus 0.5 feet is equal to 207 11 feet. Now, for the length, for the spring BD. Spring BD, we have a length of 0.5 feet. And BD man, change niya is simply 0.5 minus 0.5 is 0. Potential energy niya is, yung sabi doon sa problem, we have 2 pounds per inches. Potential energy G, we have 2 pounds per inches, which is just equal to 24 pound per feet. Kaya natin siya gawing feet because by feet yung natin. So, ito na. V1 is equals to summation of 1/2 K change of squared simply equal to 1/2 times natin is 24 pound per feet, then times natin yung 0.6180 squared plus 0.20711 squared plus 0 squared. Solve natin. Pasagad. So we have 1/2 times 24 times natin into 0.422418. V1 is equals to 5.09 LB by feet. So, yung M natin, which is, so, tama. Pause na, pause. So, if ito yung position 1 natin, pause 1. Ito yung position 2 natin, pause 2. Where, yung C natin, T1 plus V1 is equals to T2 plus V2. 0 plus 5.09 0983 is equals to 1 half times 0.93168 slug ito squared plus 1.0294. V sub 2 squared is equals to 87.300 at 345. V sub 2 is simply 9.35 feet per second.
Impulse and momentum. So the method of impulse and momentum is particularly effective in the study of impulsive motion of a particle. When a very large force called impulsive force are applied for a very short terminal of time change of t, since this method involves the impulses average of F times change of t of the forces rather than the forces themselves, assuming that all non-impulsive forces are negligible, we write m mv1 plus summation of f average change of t is equals to mv2. In this case, the impulsive motion of several particles, we will have this same formula. In the particular case, when the sum of impulses of the external forces is 0, to summation of mv1 is equals to mv2, that is the total momentum of the particles is considered for two particles. This is reduced to MAVA plus MBVB is equals to MA V prime A plus MB V prime B. Capital A, capital A, capital A. Okay. So a truck is traveling down a road with a 3% grade at the speed of 55 miles per hour when the brakes are applied. Knowing the coefficient of friction between the road and the flatbed trailer shown are mu is equals to 40 and uk is equals to 0.35, determine the shortest time in which the rig can be brought to stop if the load is not to shift.
Applied brakes to slow it down. To slow it down, yeah, 20 miles per hour. If yung static friction daw is 0.6, determine the shortest time for the truck to slow down. So, diwa muna natin. theta natin is equals to tan 4 over 100 equals 2.29 degrees. Kung ito, impact and momentum, V1 plus summation of 1 minus 2 equals to mv squared. Assume natin na positive yung this direction, m v1 plus wt sine theta minus ft is equals to mv2. So if yung velocity natin is 60, v1 is equals to 60 miles per hour, gawin natin 88 feet per second. V2 na 20 miles per hour is equals to 29.33 feet per second. Yung n natin is equals to w weight cosine theta. Weight is equals to mg, and f, yung force natin is mu times Newton is equals to mu times w sine cos theta. So with all that, ilagay natin ito lahat dito. So m times 88 plus m times 32.2 times t times sine 29 degrees minus 60 times natin ng m times 32.2 cosine 2.29 degrees times t is equal to m times natin to 29.33. Cancel natin yung mga m. Since yung hinanap natin is time, t, solve muna natin to. $29.33 times is equals to 88 plus 32.2 times sine 29 sine 2.29 sine 2.29 ito sine 2.29 plus 1.2 minus 60 minus 60 times 32.2 cosine 2.29 times 32.174 280 times natin to 60 times 60 1930.4. Oh! So after cancelling the m, we have t is equals to 88 minus 29.33 all over 32.2 times natin sa 0.60 na static friction cosine 2.29 minus sine 2.29. 58 minus 29. 58.67 all over 18.01794. So dividing, we have t is equals to 3.26 seconds. So the shortest time needed for the truck to slow down from 60 miles per hour to up to 20 miles per hour is the truck only needs, the shortest time possible is 3.26 seconds. That would be all. Thank you.